Doric finished the book. That's surprising.
So we're starting at chapter 30, and what we're going to ask is, if we have an equation ax squared plus bx plus c is equal to 0, what are the possibilities of roots for the equation? X is going to be minus b plus or minus the square root b squared minus 4ac divided by 2a, right? So case 1, we could have two real roots. Yeah, two real roots. So M1, M2. Or case 2, we could have two real roots that are the same. So I could have M1, M1. They could be the same real roots. Or I could, case 3, the other case is that the square root guy under here becomes imaginary, and then I could have imaginary roots. Alpha plus or minus beta, that's not beta, beta I. So I could have two imaginary roots, alpha plus or minus beta I. So those are my three cases if I have something like that. So in section 30-1, what we're going to do is we're going to take a second order differential equation, ay double prime plus by prime plus c y is equal to 0. And we're going to, from it, come up with a characteristic equation. And the characteristic equation is going to be a r squared plus b r plus c is equal to 0. So we're replacing the derivative with something else. Well, why don't we not go there yet? Why don't we go someplace different for a moment? Let's assume that this guy has an answer, and y is equal to e to the rx. Let's just assume that he has an answer that looks like that. And then I look at y prime, that's r e to the rx. And I look at y double prime, and that's r squared e to the rx. And then I say, well, that means that a r squared e to the rx plus b r e to the rx plus c e to the rx is equal to 0. Is e to the rx ever 0? No, because that's a function that looks like that, and it's never 0. Or no, something that looks like that, but whatever it is, it's never 0. Okay, so I can divide by that, and I can have a r squared plus b r plus c is equal to 0. And we call this our characteristic equation. So I skip all that stuff before, and I take the differential equations and I write down the characteristic equation. Well, now that I have that, I can have my roots of that can be two distinct real roots, two of the same real roots, or imaginary complex roots, complex conjugates of each other. Those are my three possibilities. That's the same place I started with. So in chapter 1, we're taking this and we're looking at the case where I have two distinct roots. So r is going to be equal to m1 and m2. And I'm saying, if that's the case, then the answer to my differential equation is going to be y is equal to c1 e to the m1x plus c2 e to the m2x. And that's just going to be my answer. So I'm going to take a second order differential equation, I'm going to find its characteristic equation, I'm going to solve for its roots, and then I'm going to write down my answer. That's all I'm going to do. Unless I want to check my work, then I would check my work to see if it was true. Okay, so that's all that section 3.1 is about. And it works whether it's a second order differential equation or a third or a fourth or a fifth, doesn't matter. You'd have to factor it, find the characteristic equation, factor it out, figure out what the roots are, and write down the answer. Now, it doesn't work. It only works if the a, b, and c's are constant. It doesn't work if they're functions of x. So if a can't be x squared plus 1, for example, that wouldn't work. All right, but that's all the theory we got. We'll look at problem number 1. And problem number 1 says 3y fourth derivative minus 7y third derivative plus 2y is equal to 0, and state whether each differential equation is homogeneous or non-homogeneous. State the order of each equation. All right, so first of all, we'll come up with order, and the order is 4. So the highest derivative is the order of the equation, and the equation is homogeneous. And it's homogeneous because it's equal to 0. So if I had a plus 1 over here on the other side of the equation, it would not be equal to 0 because the 1 would go over to the other side. So it's homogeneous. If I look at number 2 is non-homogeneous. I have a constant there. Look at 3, that's non-homogeneous because that plus 6 could be on the other side of the equation. I look at 4, homogeneous, 5, homogeneous, 6, non-homogeneous, 7, non-homogeneous, 8, homogeneous. So it's homogeneous if it's equal to 0, non-homogeneous if I can't put it in a form where it's equal to 0. Okay, so that's problem number 1. Going down to problem number 10, we're going to solve. So I have y prime plus 4y minus 5y prime double prime y is equal to 0. Okay. So I'm going to say, okay, I've got a characteristic equation. It's going to be r squared plus 4r minus 5 is equal to 0. I can factor that. R plus 5, r minus 1 is equal to 0. I find that my r's are minus 5 and 1. And I find that my solution, y to the x, is going to equal c1 e to the minus 5x plus c2 e to the x. Now, c1 and c2 are constants of integration, which are part of the problem because I have a first derivative and a second derivative. If I had initial conditions for y prime and y double prime, then I could solve for c1 and c2. I don't have that. All right, well, that's all well and good. We'll check it. So checking. Y is equal to c1 e to the minus 5x, c2 e to the x, y prime minus 5 c1 e to the minus 5x, plus c2 e to the x, y double prime 25 c1 e to the minus 5x, c2 e to the x. Okay, and I've got one of these guys, and 4 of those guys, and minus 5 of those guys, or plus 5 of those guys. Minus 5 of those guys. And when I get done, I want to have 0. Okay, so I've got minus 5c1, minus 20c1, plus a 25c1. Those guys go away. I got minus 5c2, plus 4 plus 1. Those guys go away. 0 is equal to 0. I check. Okay, I'm looking at problem number 17. I've got 2y double prime plus 13y prime plus 15y is equal to 0. I have a characteristic equation 2r squared minus 13r plus 15 is equal to 0, and that factors maybe 2r, r. Okay, so if I go minus 5 minus 3, I would get minus 13 and be there. So r is going to be 3 over 2 and 5. So I can write down my answers. Y of x is c1e to the 3 over 2x plus c2e to the 5x. Normally we do it alphabetical order, negative guys first on the exponent, bigger to smallest negative to biggest positive, in that order. But there's no requirement that you do it that way, just what we normally do. I'm going to check my work. If this is so, then y prime would be 3 over 2 c1e to the 3 over 2x plus 5 c2e to the 5x, and y double prime would be 9 over 4 c1 e to the 3 over 2x plus 25 c2 e to the 5x. And when we get done, we want it to be 0. And back to the original equation, 17, I have 2 of them, minus 13 of them, and 15 of that guy. So we'll go, I have 50 positive, I have 65 positive, and I have 65 negative. That term goes away. I've got 15 minus 39 over 2 plus 9 over 2. Okay, so this is 30 over 2 plus 9 over 2. Those guys go away as well. 0 is equal to 0. The problem checks. And I'm doing problem number 24. In 24, I have an initial condition. So I have y double prime plus 3y prime minus 10y is equal to 0, and I know that y at something, y at 24, y at 0 is 7, and y prime at 0 is 0. Okay, so that's a problem being stated. I have a characteristic equation, r squared plus 3r minus 10 is 0, and that factors r plus 5r minus 2 is 0. I find that r is equal to solution set minus 5, 2. And my final answer, well, not my final answer because I have initial conditions, c1 e to the minus 5x plus c2 e to the 2x. And then I say, well, y at 0 is 7, and y at 0, so that's going to be c1 plus c2. And then y prime x is equal to minus 5c1 e to the minus 5x plus 2c2 e to the 2x. And I find that y prime at 0 is 0. Yeah, y prime at 0 is 0, which is going to be minus 5c1 plus 2c2. So I find myself with two equations, two unknowns. c1 plus c2 is equal to 7, and minus 5c1 plus 2c2 is equal to 0. I choose to use Cramer's rule. Find that C1 is equal to 7, 0, 1, 2, divided by 1 minus 5, 1, 2. If you had a graphing calculator, you could just put those in and tell you the answer too. I mean, it'd be okay. So that's 14 divided by 5 plus 2 plus 5 is 7. So C1 is 2. Well, if C1 is 2, then C2 had better be 5. Okay, so 10 minus 10 plus 10 is 0. That checks. So we know what C1 and C2 is. So y of x, final answer, is equal to 2 e to the minus 5x plus 5 e to the 2x. So that'd be my final answer. Now we're going to check our work. Y is equal to 2 e to the minus 5x plus 5 e to the 2x, y prime minus 10 e to the minus 5x, 10 e to the 2x, y double prime 50 e to the minus 5x, 20 e to the 2x, and this is 24. So I want one of these, 3 of those, and minus 10 of them. Yep, minus 10 of them, okay. So I've got minus 10, minus 30, plus 50, that term goes away. I've got minus 50, plus 30, plus 20, that term goes away. 0 is equal to 0, and my work checks. And section 3.1 is done. Now we're going to move to section 3.2. 3.2 has to do with the case of repeated roots and complex roots. So if I have repeated roots, my r's are m and m, they're the same guy, then my answer is going to be in the form y of x is equal to c1 e to the mx plus c2x e to the mx. And if I have complex roots, r is equal to alpha plus or minus beta I, then my answer is going to be y of x is equal to e to the alpha x c1 cosine beta x plus c2 sine beta x. Tell me the author did not put them in the other direction, sine first and cosine second. He did. Okay, so he's calling it sine, cosine. There's no difference in those answers, whether I go one way or the other. So we'll call it C1 sine beta x, C2 cosine beta x, to be consistent with the author. In the differential equation class, the author goes the other way, naturally. 6 of one, half a dozen the other. So those are the two cases we're dealing with. And now we're looking at the problem set. And we're saying, we're starting with number 1. Okay, so problem number 1, y double prime minus 4y prime plus 4y is 0. I have a characteristic equation, r squared minus 4r plus 4 is equal to 0. I can factor that r minus 2 is equal to 0. So my r is a repeated root 2 and 2. So my answer would be y of x is equal to c1 e to the 2x plus c2x e to the 2x. And now I would check my work to make sure it was right. If y is c1 e to the 2x plus c2x e to the 2x, then y prime would be 2 c1 e to the 2x plus c2 e to the 2x plus 2 c2x e to the 2x. And y double prime would be 4 c1 e to the 2x plus, I got a c2 and then I got a c2, two c2's over here, so I got 3 c2's e to the 2x plus 4 c2x e to the 2x. Hope I didn't, oh I do hope I skipped enough steps. And I need one of them, minus 4 of them, and 4 of this guy. Okay, so I've got 4, I got another plus 4, I got minus 8. Those guys go away, I have 0 of them. I have minus 4.
You have a problem?
Yeah, no I don't. No problem. This is a 2, that's a 4. The derivative, no it's not. C2 e to 2x plus that. Oh, right here. This is 2 of them because I have to take the derivative of it plus another 2 of them. So that's the 4 guy. Alright, now I don't have any problem. Now I got 4 and minus 4. They go away. I have 4, 8, minus 8. They go away. I have 0 is equal to 0, so my work checks. Line number 10 next. I have y double prime plus 12y plus 36 is equal to 0. If I write the problem down right, I have a characteristic equation, r squared plus 12r plus 36, and I can factor that. R plus 6, R plus 6, and my r's are going to be minus 6, a double root. I can write down my equation. My answer, y of x is equal to c1 e to the minus 6x plus c2 e to the minus 6x. I can then check my work. Y is c1 e to the minus 6x, c2 e to the minus 6x, and we remember that there's an x there that we didn't put in, and that holds us over y prime minus 6 c1 e to the minus 6x plus c2 e to the minus 6x minus 6 c2ex e to the minus 6x. Y double prime equals 36 c1 e to the minus 6x. Okay, so I've got a minus 6, I got a minus 6, that's minus 12 c2 e to the minus 6x. And then I got plus 36 c2x e to the minus 6x. And I got one of these, 12 of those, 36 of that guy. I'm supposed to be 0. I've got 36, I got another 36, which is 72, and then I've got a minus 72, they go away. I've got a 12, I've got a minus 12, they go away. I have a 36, another 36, a minus 72, they go away, 0 is equal to 0. Problem number 10, checks. Am I going fast enough, gentlemen? 17. So we're looking at problem number 17. And why did I skip all the way up to 17, I wonder? Anyway, I've got y double prime plus 25y is equal to 0. And I've got y at 0 is 2. And y prime at 0 is 0. Okay, that's what I have. Okay, so I got a characteristic equation. R squared plus 25 is equal to 0. R is equal to plus or minus 5i. That goes over there, becomes a negative number on the other side. I take the square root of it, get plus or minus 5i because it's negative. Okay, so I'm in the form alpha plus or minus beta I, and there's no alpha. Alpha is 0, so there's a 0 sitting out there. So anyway, y of x is going to be c1 sine 5x plus c2 cosine 5x. And now we're going to apply our initial condition. Y at 0 is 2, which is equal to the cosine of 0 at 0 is 0, c2. So that implies that c2 is equal to 2. So y of x becomes c1 sine 5x plus 2 cosine 5x. Y prime of x is going to be 5 c1 cosine 5x minus 10 sine 5x. Y prime at 0 is equal to 0, which implies that 5c1 is equal to 0, and that c1 is in fact equal to 0. So my final answer before checking, y of x is equal to 2 cosine 5x. Okay, now I'm going to check my work. Y at 0 is supposed to be 2, check. Y prime of x is 10 minus 10 sine 5x. Y prime at 0 is supposed to be 0, check, it is. Y is equal to 2 cosine 5x. Y prime is minus 10 sine 5x. Y double prime is minus 50 cosine 5x. I'm supposed to have one of them, 0 of that guy, 25 of this guy, and when I get done I'm supposed to have 0. I do, check. It checks. Okay, number 20. You should do this tonight with your 9th grader. Number 20. Anybody have a 9th grader? Not yet? Okay. Not even close. Start early though.
Yeah.
Number 20.
Have a kid first.
Oh, bummer. Y double prime. That's what she said, I think. 6y prime plus 25. 25y is 0. And y at something and y prime at something is something. Y prime, y at 0 is 0. And y prime at 0 is 8. Alright, so I have a characteristic equation, and m, are we using m's or r's? I forget.
R's.
Doesn't matter. M squared, r squared minus 6r plus 25 is 0, and I go to factor that, and that's not factoring very well, is it? Okay, so R is going to be, I'm going to use the half quadratic formula. So it's going to be 3 plus or minus square root of 9 minus 25. And so that's R is going to be 3 plus or minus 4i. Alright, that being the case, y of x is going to be e to the 3x c1 sine 4x plus c2 cosine 4x. And we'll apply the initial conditions. Y at 0 is supposed to be 0. It's supposed to be 0. Okay, well this is a 1. That's a 0, so it'd be C2 C2, implying C2 is 0. So I got y of x is equal to e to the 3x c1 sine 4x. Y prime of x is 3 c1 e to the 3x sine 4x plus 4 c1 e to the 3x cosine 4x. Y prime at 0 is supposed to be 8. Okay, the sign is of 0 is 0, so that term goes away. This becomes a 1, that becomes a 1. 4 c1, implying c1 is equal to 2. So my final answer would be y of x is equal to 2 e to the 3x sine 4x. And then we'd have to check our work. So y prime of 0 is supposed to be 0. Check it is. Y prime of x is 6 e to the 3x sine 4x plus 8 e to the 3x cosine 4x. Y prime at 0 is supposed to be 8. Check it is. Continuing on, y is equal to 2 e to the 3x sine 4x. Y prime is 6 e to the 3x sine 4x plus 8 e to the 3x cosine 4x. And y double prime is 18 e to the 3x sine 4x plus 24 e to the 3x sine 4x plus 24 e to the 3x cosine 4x minus 32 e to the 3x sine 4x. Seems like I should be able to combine some of those, but I don't really need to. Okay, so I have 1 of them, minus 6 of them, and 25 of this guy. And when I get done, I'm supposed to have 0. Okay, so I've got 50 sines minus 36 sines, 36, and it doesn't work. Oh, I know why it doesn't work. This is supposed to be a cosine over here. There. Now, does it work now? What's 36 minus 36 plus 25 minus, shit, too late in the day. So I got 50 minus 36 plus 18 minus 32, 0. So I have 0 of the sine guys. And then I got 8 times 6. Yeah, we got minus 8 times 6. And then I've got plus, oh, that's 48 plus 48. So those guys go away. 0 is equal to 0, so I check. Okay, done with section 3.2. Moving on to section 3.3. So now we're going to deal with non-homogeneous, if I could spell it, equations. So I'm going to have some differential equation which is going to be a homogeneous guy, and then it's going to be equal to something over here which makes it non-homogeneous. Okay, so what I'm going to do is I'm going to go and find the characteristic equation of the homogeneous guy, solve it, get a y sub c in my answer, just like I did in the last section. Then I'm going to look at what's on the other side of the equal sign, and I'm going to write a y sub p based on whatever that is. I need it and all of its derivatives. So if I have an x squared over here, then I'd go a x squared plus bx plus c. If I had a sine 2x over there, then I'd say y sub p is a sine 2x plus b cosine 2x. And then I'd run that particular solution through the differential equation to solve for a, b, c, how many variables I have. And then my final answer is going to be y is going to be y sub c, the homogeneous solution, which we just solved for, plus y sub p, the particular solution. And because this is Tech Math 4, what's on the other side of the equation is always going to be relatively okay. Okay, so there's not going to be anything weird about it. In the differential equation class, we have weird things over there, and we have other methods that we have to worry about. But you guys don't deal with weird. All right. So that's the name of that tune. We're looking at problem number 1. Okay, so number 1. And I've got y double prime plus y prime is equal to sine x. So I look at the characteristic equation of the homogeneous solution, r squared plus r is equal to 0. And I factor that r plus 1 is 0. I find that r is equal to 0 or minus 1. I find that y sub c is going to be c1 plus c2 e to the minus x. So there's an e to the 0 sitting there. Well, e to the 0 is 1, so I don't write it down. But that root of 0 ends up being there too. Okay, so that's that guy. And then we say, well, y sub p is in the form a sine x plus b cosine x. And that y prime of p is equal to a cosine x minus b sine x. And y double prime of p is minus a sine x minus b cosine x. And I've got one of these guys, one of those guys, 0 him. And when I get done, I want to have sine x on the other side. So I've got a minus b cosine x, and then I've got minus a minus b sine x on one side of the equation, and on the other side of the equation I just have sine x. Well, I don't have any cosine on the left hand side, so a minus b has to be 0, and minus a minus b has to be 1, because that's what's sitting in front of the sine guy. Okay, that being the case, I can solve for a. A is 0, 1, minus 1, minus 1, and divided by 1, minus 1, minus 1, minus 1. So I got 0 minus a minus, so that's a plus 1. Got minus 1 minus a minus 1 gives me a minus 2. So a is going to be minus 1/2. Well, if a is minus 1/2, then b has to be equal to 1/2. Otherwise, we wouldn't be there. Now, a has to also be minus 1/2, because minus 1/2 minus a minus 1/2 is 0. Minus a minus 1/2 minus a minus 1/2 is 1. So I have my a's and b's. So y sub p is in the form minus 1/2 sine x minus 1/2 cosine x. And my final answer is yc plus yp. So my final answer is going to be c1 plus c2e to the, and I forgot already, minus x minus 1/2 sine x minus 1/2 cosine x. And then I say, okay, well that's fine. Let's see if it checks. Y c1 c2 e to the minus x minus 1/2 sine x minus 1/2 cosine x. Y prime minus c2 e to the minus x minus 1/2 cosine plus 1/2 sine. Y double prime c2 e to the minus x 1/2 sine minus 1/2 cosine. No, plus 1/2 cosine. And anybody remember the original problem? Okay, so I have one of those and one of those, and when I get done, I want to see sine x when I get done. Okay, so that's the plan. So I've got minus c2 plus c2, they go away. I got minus 1/2 cosine plus 1/2 cosine, they go away. I got plus 1/2 sine, that's sine x. My work checks. Okay, moving on to 10. I got y double prime minus 4y is equal to e to the x minus 2x. Okay, so
Plus 4y.
well, I don't want to solve that problem. That's too easy. Oh. Alright, so I've got a characteristic equation. And the characteristic equation is r squared plus 4 is 0. R is going to be plus or minus 2i. Y sub c is going to be c1 sine 2x plus c2 cosine 2x. Alright, now y sub p is going to be in the form a plus bx plus c e to the x. So I need something that's the function x something that's the derivative of the function x, and something that represents all the derivatives of e to the x. And all the e to the x guys are e to the x. Y prime p. B plus c e to the x. Y triple prime p. C e to the x. Okay, and this is number 10, so I want one of these, 0 of them, 4 of those. Normally I don't put the 0 down. And when I get done, I want e to the x minus 2x. Okay, well, I've got 4 plus 1 is 5. Oh, how did I hose myself over? Oh, no, that's not a problem. Everything's fine. All right, so I've got 5 c e to the x's. I've got plus 4b x, and then I got plus 4a. Okay, that'll work. That works. Okay. I was being confused by the facts. Anyway, I've got 1 e to the x. I have 5c e to the x, so c has to be 1/5. I have 4b, that has to equal to minus 8, so b has to be minus 1/2, and a has to be 0 because I don't have any unit term over there. Okay, so my final answer, y of x, well, we won't write that down yet. Y sub p minus 1/2 x plus 1/5 e to the x. The unit term was a, so there's b, so that'd be okay. So now we're ready to write down the final answer. So y is equal to yc plus yp. Y of x is equal to c1 sine, yes, what do you need?
No, you're having class.
Plus c2, so what? Interrupt anyway. Minus 1/2 x plus 1/5 e to the x. Alright, so now we have to check our work. So that would be my final answer. Yeah, someday you'll have a classroom like this that's perfect, not those stupid math things that you have to do. Sine 2x plus cosine plus c2 cosine 2x minus 1/2 x plus 1/5 e to the x. Y prime 2c1 cosine minus 2c2 sine minus 1/2 plus 1/5 e to the x. Y double prime minus 4c2 sine minus 4c2 cosine, that guy goes away, plus 1/5 e to the x. Okay, well, one of those guys and 4 of them, 0 of them, and when I get done, I best have e to the x minus 2x, otherwise I'm going to be very unhappy. Okay, so I got 4, I got minus 4, I got 4, I got minus 4, they go away. Here I've got a minus 2x. I got 4/5, 1/5 plus e to the x. Check. Okay, so number 10 is fine. Moving on to number 18. Yeah, that's a new robotic chair. Obviously he doesn't know to interrupt because clearly he should do that, right? Because we need a break. because I need to go get a can of Coke or something. Control F11. Control Shift F11.
Yes, please.
Alright, going again, and we're doing number 18. Y double prime minus 4y is equal to e to the minus 2x. Okay, so I got a characteristic equation of the homogeneous solution, which would be r squared minus 4 is equal to 0. R is going to be plus or minus 2. Y sub c, c1 e to the minus 2x plus c2 e to the 2x. Now, you notice that part of the homogeneous solution is what's on the other side of the equal sign. So if I were to be really stupid and say, well, y sub p is in the form a to the e to the minus 2x, and then I'd say y prime of p is equal to 2 my a e to the minus 2x, and y double prime of p is equal to 4 a e to the minus 2x, and I called one of them and minus 4 of them, and I've got 0 is equal to e to the minus 2x. What the hey? So when you have a situation where your particular solution includes one of the answers to the problem, you add something. So you're supposed to be picking out the forcing, it's called the forcing function. The forcing function and all its derivatives, where you'd have to throw in an antiderivative and say y sub p is going to be a e to the minus 2x plus b x e to the minus 2x in order to get a right answer. Otherwise you're hosed, you'd never find the right answer. Y prime of p minus 2a e to the minus 2x plus b e to the minus 2x, y double prime p 4a e to the minus 2x minus minus 2bx e to the minus 2x. Okay, so I got minus 2 minus another 2, so that's minus 4b e to the minus 2x plus 4bx e to the minus 2x. And I want one of them minus 4 of him, and when I get done I have to have e to the minus 2x. Okay, so I got 4 minus 4. I've got minus 4 plus 4. So the only thing I have left over is minus 4b e to the minus 2x, and I need a 1 there, so that means that b has to equal minus 1/4. So my final answer, y is equal to c1 e to the minus 2x plus c2 e to the 2x plus minus e to the 2x minus 1/4 x e to the minus 2x. So, okay, so I got the right answer. Now we're going to check our work. The reason we check our work is that in some things we do in math, we have a gut feeling that it's right. Differential equations, we have no clue. So we always have to check our work. Until we check it, we really don't know that we have a right answer. Plus C2. Now in your case, you'd say, well, Doug's working it, therefore it has to be right. So that has to be one way to go, right? Yeah. Y prime minus 2 C1 e to the minus 2x 2 C2 e to the minus e to the 2x minus 1/4 e to the minus 2x plus 1/2 x e to the minus 2x. Y double prime. 2c1, 4c1 minus 2x. 4c2 plus 2x. This is going to be a half plus a half plus e to the minus 2x. And then I'm going to have this guy, which should be minus x e to the minus 2x. Okay, and when I get done, I want e to the 2x, e to the minus 2x. Yeah, e to the minus 2x, okay. And I've got one of them, minus 4 of those guys, 0 of these guys, but I normally don't put the 0 in. Alright, so there's minus 4 plus 4, there's minus 4 plus 4. There's plus 1 minus 1. The only thing that's left over is e to the minus 2x. The work checks. Okay, one more problem. Number 20, which is probably one with an initial condition in it, I would hope, yes. Now we could look in the back of the book and see if we got it right. That'd be another possibility. Can't imagine why we'd want to, but we could do that. Number 20. Y double prime plus y prime equals sine x, and y at 0 is 0, and y prime at 0 is 0. Okay, 4 overriding the problem now, right? I have a characteristic equation. R squared plus r is 0. I have r plus 1 is 0. R is equal to solution set 0 or minus 1. Y sub c, the characteristic answer to the characteristic equation, c1 plus c2 e to the minus x. My y sub p is in the form a sine x plus b cosine x. Y prime is a cosine minus b sine. Y double prime is minus a sine minus b cosine. When I take one of them and one of them, I'm supposed to have sine left over. Okay, so I've got the sine guy is going to be minus a minus b sine, and the cosine guy is going to be a minus b cosine. So I've got that a minus a minus b has to be 1, and a minus b has to be 0. All right, I'm not going to use Cramer's rule. I'm going to add them together. Minus 2b is 1, meaning b is equal to minus a half. Well, if b is minus a half, then a is also minus a half. And now my y sub p becomes minus a half sine minus a half cosine. And y, my final answer, y sub c plus y sub p, is going to be y is equal to y sub c, c1 plus c2 e to the minus x, minus 1/2 sine minus 1/2 cosine. Okay, we have initial conditions, so now we're going to have to solve for them. So y at 0 is 0, which is going to be C1 plus C2. That guy's 0 minus a half. So I got C1 plus C2 is equal to 1/2. And I'm taking y prime minus C2e to the minus x minus 1/2 cosine plus 1/2 sine. Y prime at 0 is 0, I think.
Yes.
Yes, it is. Which is going to be minus C2 minus 1/2, that guy's 0. So that implies that C2 is equal to minus 1/2, and that if that's the case, then C1 has to be 1. So now we're going to write our final answer. Y is equal to 1 minus 1/2 e to the minus x minus 1/2 sine x minus 1/2 cosine x. And then we're going to check our work. So that would be y of x is equal to this. That's my final answer. Now we're going to check. Y is 1 minus 1/2 e to the minus x, 1/2 cosine sine x minus 1/2 cosine x. Initial condition y at 0 is supposed to be 0. 1 minus a half minus another half is equal to 0. Check. Y prime is equal to 1/2 e to the minus x minus 1/2 cosine x plus 1/2 sine x. Y prime at 0 is supposed to be 0. 1/2 minus 1/2. Check. Alright. At that point, we could find the first and second derivative all over again. Well, we got enough room. We can probably do it with what we got. Alright, so we'll just do it with what we got. Y double prime minus 1/2 e to the minus x plus 1/2 sine minus plus 1/2 cosine. We have one of those guys and one of those guys. Yes, we do. And when we get done, we want sine x. Okay, so plus a half minus a half, he goes away. Minus a half plus a half, he goes away. 1/2 plus 1/2 is 1. Sine x, check. Okay, gentlemen, with that we are caught up